I want to make sure you know it because I guarantee you, I could just have given you a quiz on this right now, and there may be some of you that have got most of them right, but I guarantee almost everybody would miss something just because of even a silly mistake, which is easy to do. All right, so in this problem, remember, if you're thinking PEMDAS, because that's all this is, remember at the very beginning of school, we had a test that had PEMDAS on it, and it did not go well. So that's why I'm kind of, hopefully this will work now, I don't know. So PEMDAS parentheses, there's nothing inside the parentheses to simplify, right? So we don't have to worry about the P in PEMDAS. But there is an exponent, it's right here. What does it get applied to in that problem? Yeah, both terms, right? So I'm going to copy the 17z down, and I'm going to say, okay, the 3 gets squared and the z gets squared. And I might not need to write the step in that I just wrote because maybe I can do that in my head, and I could have skipped this second line that I wrote. But really, that ends up being 17z, 3 squared is 9, and then I got a z squared, right? All right, so now what do I do?
Get all the exponents.
Yeah, I'm ready to multiply, aren't I? And so I got two things to multiply. I need to multiply the number. 17 times 9, let's just go ahead and do it. It's what, 3 carry your 6, isn't that what, 153?
Yeah.
Okay. Now, remember that when we multiply, this is where we're starting to use those exponent rules. This is a z to the first power. The lazy math guy just didn't write it, did he? You may not need to do that, but it's helpful if you find yourself kind of getting things wrong. How many z's do I have in all if I multiply z times z squared? Yeah, we add the exponent. There's one of them in the first parentheses. There's two of them in the second one. So it's z to the 1 plus 2, which is 3 power. So it would be 153 z cubed. Okay, that would be the answer to 14. Notice, am I working the odds? So are you actually doing what I ask if you're not working the evens with me? No, okay, because I'm not working your homework problems anymore. I kind of figured it needed to be different. Let's look at, what's another one that looks hard to you? I don't mind working an odd, but 11? Okay, let's try it down here. Oh, you can't put it in the calculator.
Yeah.
Because you can use your calculator to help you out with some of the number part, but there's an X in there, and your calculator didn't do the X's.
Yeah.
Okay, so that 4 is on a set of parentheses, so doesn't it go with everything in the parentheses? Mm-hmm. So if you want to write out what you got to do, you got to put that 4th power with that 5, and then on the X, it's X to the 7th raised to the 4th power. Now 5 to the 4th power, that's 5 times 5 times 5 times 5, or you can put, if you're putting it in your calculator, you put in 5, you hit that little thing that looks like a housetop, and you put a 4, and that would give you 5 to the 4th power. Y'all see where the little housetop thing is on your calculators?
It's right below clear.
Right, that's on the very far right column. That's going to be what, I believe it's 625. I don't have a calculator, but I believe it's 625. Is that what it is?
Yeah, 625.
Okay, so that part's 625. What do you do with this x to the 7th raised to the 4th power? You have a power raised to a power. What did those rules tell us to do? You multiply. When you have a power to a power, you multiply the exponent. So it's x, and 7 times 4, you multiply, and you get 28. So that you can apply it. Because do you know if you know how to do it, if I do it for you and then you do it? If you don't look when you do it, you might, actually be able to see if you understand it. Yeah, not everybody does. Okay, so let me work the even when you have a question and show you how to do it, because how to do it is better than here's the answer. Okay, so that's 100x to the 5th. It looks like it's got a decimal in it, but it really doesn't. Now there's a couple of things going on here. There's actually several different things we're going to have to do to simplify here. First of all, let's look at just what I would do when I have a fraction is look at the whole numerator first, and then the whole denominator. I would put the denominator out in after I messed with the numerator here. If you have a cube on the outside of that parentheses, doesn't that mean that cube goes with everything in the parentheses? Right? Okay, so that means 5 gets cubed, and it also means that x squared gets cubed. So let's go ahead and just kind of finish that top part up. It's a lot of times it's just best to just kind of work all the top part and then work all the bottom part. What's 5 cubed? 5 times, and again, you could put that in your calculator by putting a 5 and then a house, that little caret symbol, and then a 3. It's 125, good. Now, x squared cubed, what are you supposed to do with that square and that cubed? You multiply. Power to power, you multiply. What is 2 times 3? 6. Okay, I'm not going to write that in as a separate step. I'll just put it, there's some of this we can definitely do in our head. Now on the bottom, I'm just going to keep writing 100, x to the 5th. Hard to read that. So I've got 100, x to the 5th. Now that there's not really much to do on the bottom, is there? It's already kind of done for you. So now what do you do?
Then you subtract the 5.
Yeah, if you want to, let's say you want to do your x's first. There's more on the top. In the exponent on the top bigger, it's a 6. So your answers are going to go on the top for the x part. It's 6 minus 5 because you got a fraction, so you subtract the exponents, right? Okay, so what is 6 minus 5? 1. I could write x to the first power, or I could just write x, right? We would probably just write x. Now what about 125 over 100? What are you going to do with that? You could, well, if you divided it, you'd get a decimal. Remember, we don't like decimal answers, and that's another thing. I have not been counting off when you give me a decimal answer. From now on, I'm going to, because you don't want a decimal answer. It is going to hurt you in everything you do from here on out, unless it's a word problem. We want to reduce the fraction is what we want to do, because we're going to do stuff with this when we do logarithms, and we can't have that decimal in there. If I notice that both of these are divisible by 5, there's something bigger they're divisible by. Actually, 25 would work, right? How many? If you had $1.25, how many quarters would that be? Yeah, so it's 5 basically. 5 goes into 125 5 times. How many times is 25 go into 100? 25 goes into 125 5 times. 25 goes into 100 4 times. You need to write your answer as 5 over 4x. Okay, that's your answer. It's 5 over 4x. You could write it as 5x over 4. For what we're getting ready to do, this would be the best way to write it. If you put 1.25x, it's not that it's wrong. It's just that we really don't want to use decimals so much unless we have to in algebra. It's just not usually what's going to get us where we need to go. Okay, so for 18, we have 2 sets of parentheses. In the first one, we have a to 11, and then we have b to the 11th power. And then all of that's raised to the 5th power. And then over here, we got b 9 over a 7, and all that's raised to the 7th power. What do you kind of see here when you look at it? Anybody have an idea what you should start kind of thinking you're going to need to do? How could you break this apart a little bit? Yeah, you got that. Let's first look at this first term, a to 11 divided by b to 11 to the 5th power. First of all, you got a fraction raised to a power, right? So I know that 5 is going to get put on the top and the bottom, right? And there's already an exponent in there, so it's like what we're really looking at here is a to the 11th raised to the 5th power over b to the 11 raised to the 5th power. And let's finish that piece up, if that's okay. What do you do like that a to 11 to the 5th power, or the 11 times 5, right? Yeah, you got your base of a. Oh, I hit something weird. Okay, you got the base of a. Let me come down here. 11 times 5 is 55. We're multiplying because it's a power to the power. And on the bottom, what are we going to have? Yeah, b to the 55, because 11 times 5 is 55. Now, the other thing's going to work the same way. We're going to have, that's not a negative, that was just where I messed up, b to the 9th raised to the 7th power. And that 7 also goes with the denominator. Some of you guys can do this in your head, and that's fine if you can. If you find yourself trying to do it and you mess up, go back to writing more stuff down. That's how you kind of get past making errors. On the top, we're going to have b. And what are we going to do with that 9 and 7? Multiply. 9 times 7 is 63, okay? And then on the bottom, we're going to multiply that 7 and that 7. That makes 49. Okay, so now, if you look at it, I've got, am I done? No. How do you know we're not done?
Because you can cross multiply.
Well, you would cross multiply if there was an equal in the middle. Yeah, we got to reduce. There you go. If there's an equal, you cross multiply. If it's multiplied, we got to reduce. Now, wouldn't it be helpful if I wrote it this way? Let me write this way. Let me put it in alphabetical order on the top and the bottom, because it is in alphabetical on the top, but look at the bottom, the B's first. Doesn't that line everything up nicely for me if I'll put it in alphabetical order? That's a 55 too, isn't it? Now what do? At least I got stuff where it's lined up pretty nicely.
You can get rid of the, no.
You kind of look at it in two parts. Remember, we got the A part here. If you just had that, wouldn't the rule be that you would subtract the exponents and write the answer on the side that had the bigger exponent? You got A55 on top, you got A49 on bottom, so you got more, a higher exponent on the top, don't you? So that would be A to the 55. You're going to subtract. Do you remember that that's the rule? When you have a fraction, you subtract the exponents. A fraction is division, isn't it? Okay, so that goes on the top. Where's the bigger exponent for the B?
Top.
Still on the top. So it's going to be subtract the B exponents, if I can get it to fit in there. And there would be a 1 left on the bottom. If you ever are doing this and you're going to fill in anything that ends up empty with a 1, because basically things are just canceling out, like I showed you earlier in the class. Your answer would be what? 55 minus 49 would be 6. And B to the 63 minus 55 would be 8. Yep. And it would be over 1, but we're going to put it over 1? No. That would be your final answer there.